check. Hello. Check. Hello. Good morning, everybody. See, you guys are starting to log on. We're going to give it a few minutes for everybody else to log on here. Hopefully, we don't have audio issues like we did last time. Let's get the chat box going. Let me know if I'm sounding okay for you guys today. And why don't you guys pop in the chat box where you guys are viewing from, and we will get started here shortly. All right. Good morning, everybody. We'll get started here. Hopefully, everybody's having a nice Friday. I know we usually do these on Wednesday mornings. It's been a bit crazy over here at ATI, but crazy in a good way. And I'm sure you guys are just as busy at your guys' facilities. We just got off of the Design to Part show in Schaumburg yesterday. It was really good. I saw some of you out there. So today I want to talk about a few things. We're going to talk mainly about setting systems. We're going to talk about automated and semi-automated systems, and I'm going to go through a bunch of different systems that I commonly and uncommonly use to set up my parts. As always, remember, if you guys aren't able to jump on live here when I do them, when I do the webinars, I record them and I load them onto our YouTube channel. And you can always go back and review some of them. I've been trying my best to get in the description of things that I talk about in there, so you can go back and review and like, oh yeah, there's where true position is, or profile, or flip working planes. If you ever have a question of which video is which, if you remember something specific, shoot me an email. Couple training seminars coming up. We have next week at our Warsaw, Indiana facility. We're doing the blueprint hand gauge training and some microview training. A few seats left for that if you're in the Indiana area. And then June 7th through 9th, we'll be back here. I'm actually at our new Elgin Training Center today. So hopefully the Wi-Fi is better than what we had last time, if you were live last time. So we'll be doing a training here June 7th through the 9th. Same thing, hand gauge training, blueprint reading, microview, basic and advanced, and a new class we've been doing for about 2 years now, microview GD&T, where we go through every single GD&T call out and we measure it on the microview and see how the points view looks and a bunch of different other features with GD&T on that. So like I said, today we're going to talk about microview systems, as in setting up our origin, skew, and all that jazz. We're going to talk about fully automated systems and semi-automated systems, the benefits of both, recalling systems, and actually setting systems to our stage square and our fixtures. We've hit on this a little bit in some past webinars, but I really want to do a dedicated webinar just talking about this. So when you guys are programming, if you guys get a second machine, or if you go up to a larger machine, or calibration comes in and they calibrate your machine and you end up taking the stage squares off, real things to align your parts and your systems and all your programs. So let's jump into it here. Couple things with semi-automated and fully automated programs. The benefits of both that I see is fully automated systems. You can write your program, hit run, and the program runs. If it's in the same place every single time, you never have to worry about finding the part, locating it, any operators you might have. They don't have to go around and try to find any features. But if you don't have fixturing, or you have parts that you don't have anything that can restrain it, semi-automated systems are good as well. If you're going to be making a part that maybe it's the prototype, or if it's the first run and you're going to be making a bunch of different adjustments, maybe it's good to do a semi-automated program right off the bat, so you don't make a fixture or do anything with that fixture until it's a proven program. And then we can also insert recall reference systems to make your semi-automated programs fully automated. So that's the first thing that I want to do today. Is I'm going to just write a simple little program on one of these parts here. I'm going to come over to a simple flat part just to do this. Something that we've done plenty of times, and I'm sure you have with the practice slide. I'm going to do line intersection point, and we'll cover this again later as one of our specific common systems. So I'll talk about it in detail of what I'm clicking around, what I'm doing here. But I'm writing a semi-automated program. I don't have a fixture for this part. So I'm setting an intersection point and a focus point here. I should be at a high magnification. For time's sake, I will just do a low mag here. So I'm going to set my origin X and Y to the intersection point, origin of Z here, and then skew. So we have a semi-automated program here where when I hit run, I have to go find these features. So we see this prompt pop up. If you're used to semi-automated programs, this will come up saying the next tool must be located manually. And microview gives us a nice little crosshair saying where it's supposed to be on the part. If we look over here in the features list, it's an arrow saying, hey, this line is the first feature that's going to be going where this crosshair is. And in your inputs list, it also tells you what tool was used. So I say this a lot of, these are features. The black icons are features, and then the green icons over on the right are tools. This is what we want to measure, and the green ones are how we want to measure it. So it's nice right here. It looks exactly like the F-scan line here. So that tells me I just got to come over and find this feature. And you can either come over, you can right click, move here. And if you're over that feature where that crosshair is, you can hit the space bar and it'll just place that tool there. Or once we hit continue and the crosshair moves over to the bottom edge, we can move over here and you can click your tool going on there. And we hit continue. The nice thing about semi-automated programs is that the lighting and magnification still is automated, but we just have to place the tools. So again, we just click, we place our focus point, and then the program would run from there. So now let's say we got our semi-automated program going on here, but now we have a fixture. So we put this part into a fixture, and now we want to make it fully automated. What we can do is once we put it in the fixture, we run the part one time so the machine knows where that part is located. And then once we measure it one time like we just did, we can right click on the very first feature that we have and go to insert here. And we notice that dash line goes up to the very top. Whatever feature you click, it goes in above that feature. And then we can come down to our recall button down here at the very bottom row of our red icons. And we can click recall. And here, there's a few things that I have stored. I have the reference system, which the reference system is your machine 00. Microview stage glass, I actually measured the glass, and for flatness, I did a plane on there, and I stored that system. And we can talk about storing systems today. We talked about it in previous webinars, but here I'm going to do my recall reference system. Now, one common thing that people, well, two things now that comes to mind is mistakes that you can make or steps that you might skip is when I hit run, it's still going to be semi-automated. We need to highlight everything underneath that new system, that recall reference system that we did, all the way down to our next system. We need to right click on that, go to set system, and tell it what system to look at. Because if we don't do that, when we click on the line and we look in our summary tab up here, it's still looking at our parent system MCS, which is our machine coordinate system. If you ever see this, that means that it's not automated yet. So we need to highlight these, right click, go to set system, and our new system 6, which we can see at the very top is system 6 is our recall reference system. Click OK. Now the parent system is system 6. So now when we run this, it's fully automated there. So that's one common thing that I see people skip the step of is after you insert the recall reference system, you need to highlight everything from underneath it down to the next system, right click, set system, and set it to your new system up here. Another thing that I see, and I commonly do even 10 years later after programming microviews, is I forget to right click anywhere on the features list and say insert at end. Because if we don't do that, so if I go back and I have my dash line up here, if I go to measure a new feature, it's inserting it above that dash line. So you could be programming and then all of a sudden you're programming out of order because you inserted here and you forgot to insert at end. So that was a semi-automated program. Is good, like I mentioned, that if you don't have fixturing for your part and you want to just put the part on the stage, you can put it anywhere on the stage. One thing to keep in mind is whatever you skew to. So when I skew to this line, it's within 45 degrees of my machine X. Or if you skew to a Y line, just make sure that that edge, wherever you put it on the stage, is still within 45 degrees of your machine X and your machine Y. If you have it kind of, more than that, if you flip the part 90 degrees, it has a very difficult time being to measure it because the direction of the line that you did there. So you can put it anywhere on the stage with a semi-automated program, but just make sure that however you placed it on the stage is within 45 degrees of how you programmed it. So with automated programs, it's really nice because you can just put the part on the stage as long as the fixture's in the same location, click run, and you're good to go there. So when I do a fully automated program, the very first thing I do is come down here and hit recall and recall whatever I want to recall, my reference system or stage square, whatever it might be. So let's go ahead and do that. I'll come over to this part over here. And I'm going to do recall, reference system, and we're going to get to why I would want to recall my stage square here in a minute. I'm actually going to do surface lighting here. And I'm going to measure this circle as my origin. So I'll do circle. And since my very first thing in my features list is a system, because I recalled the reference system, we're going to be good to go with my fully automated program. Now, since this diameter is too large for the camera window, I click diameter, I click more inputs, and I'm using the F-scan arc tool. So I can come and tie a few of these F-scan arcs together to create one diameter. And then I got a decently straight line right there that I will use for my skew. And now, since it's fully automated, I can click run, and it goes from there. Now we can also do multiple systems, which I'll do on one of our systems that I'm going to create that we're actually not going to skew because we don't need to, and I'll show you that example. But I'm going to create multiple systems on that to be able to use rotate function and a few other functions going on there. So let's talk about the benefits of setting your system, actually storing a system to our stage square. So I'm going to come over here on my part here. We can see that I have a threaded hole fixture with different letters that tell us where to put different posts. So I'm going to move over to my left side of the machine. I'd say most of you have a stage square on your machine. So if you look at your machine, you'll see like an L bracket on the left side and the bottom edge. Sometimes we've done custom stage squares where it's on different edges of your stage, but there should be two like stock metal bars that are bolted down to your machine glass on that stage. And this allows us to be able to magnetize fixtures to it. You can place parts in the corner. That promotes easy use for fully automated programs. If you don't have a stage square, we make them in-house. If you want more information about it, feel free to shoot me an email and we can talk about that and find what size machine you have. So before I even program anything, this would be a good idea for you guys if you're not already storing your stage square and recalling your stage square instead of recalling your reference system. This might be a good thing to get into today, on Monday, whatever you guys, next time you're on the microview programming a part, is because if the stage square does move for some reason, if we take it off to replace your glass, if you take it off to put some different fixturing on there, something like that, we can always restore the stage square in the new location, and all of our programs will move wherever that stage square is. So I'm going to go ahead and I'm going to do recall reference system, and then I'm going to do line, more inputs. I'm going to use F-scan line. I'm going to come down my stage square. Actually, I'm going to move this guy. Here's a little trick while we're here. See how that tool is down here? How many of you, when you want to move a tool, move the tool and then move the camera and then move the tool? Here's a little trick that I've mentioned before, but in case you weren't on one of those or you forgot about it, if I move my camera and I hold down the shift button and I click, it brings that tool from down below to where my current location is. So I don't have to keep dragging the tool, moving it. So again, if you just hold down the shift button and you click, it brings it to wherever you clicked. So I'm going to go down the stage square here, measure a longer line. Longer the edge, the better. So I'm actually going to move my, let's see if we could see my stage square. There we go. Here's my stage square. So now I'm going to do a new line. Measure the bottom edge. That's good enough for now. So I'm going to do point, and I'm going to do intersection point between my two stage square edges. And then I'm going to set my origin. We could do, I'd say it's not super important to set an origin of Z onto it, but good practice. We're going to go ahead and do that. So I did a focus point on my stage square. So now I'll do origin of X and Y to my intersection point. I'm going to set origin of Z to my focus point, and I'm going to skew. My bottom edge is longer, so I'm going to skew to the bottom edge. And then I'm going to call this one, say you have different locations. I know I was just at last week, I was at some of our customers in Indiana around the Warsaw area, 3 locations, multiple different microviews in different locations. So instead of storing, ATI stage square, I'm going to store Elgin ATI stage square, so I know which one's which. So if I right click on that system and I go to store, I can store it and I can save it permanently. So now I'm going to start writing a program. I do file new. And the first thing that I'll do when I'm writing a fully automated program is I'm going to recall my Elgin ATI square. So now, just like the recall reference, it's going to be the same thing as, since the very first thing in my system or my features list is a system, it's going to be fully automated. Now, let's say I go and I write this whole program. The one thing that I forgot to do is I didn't save that program. So if the one thing that you need to do is, I should have saved that stage square program, because if your stage square moves, you go open up that program, rerun that program, and restore that Elgin ATI stage square so it updates the location. So all of the programs that recall that Elgin ATI stage square will look at that stored system that you stored after you ran the new program onto there. At the very end of this, if you want me to go back and redo that and rerun the stage square program, I'll go ahead and do that. If you want to see that, just pop it in the chat box. But for time's sake here, if that makes sense to you guys, we'll just keep rolling from here. Another thing that you can do is you can store individual fixtures. So if I do file new, I'm going to measure this threaded hole plate that we have. And since I have diameters here, I'm going to do circle. And then I'm going to come down a few stage squares later. Hopefully that's not moving too fast for you on the webinar. Measure another circle. And I'll set my origin to 1 diameter, and I'll skew to the other 2 circles. Now I'm going to store this as Elgin ATI threaded plate. Let's see how many characters. Let me do all those characters. Save permanently. So here's another good thing that we can do, is that we will recall the stage square, and then I'm going to recall the Elgin ATI threaded plate. Just in case one is moved off than the other just a little bit, now it's recalling both, that if our fixture moves a little bit, or anything like that, or if, let's say worst case scenario, you accidentally drop your fixture and there's a chunk taken out of it, so it's aligned differently, you would want to save this as your fixture program, and you can rerun it and restore your system on that. So it's a really good idea to set your systems before you even start measuring your part to your stage square and your threaded hole plate. It's a good habit to get into now. If you have a brand new machine and you don't have thousands of programs that are recalling the reference system, you got a clean slate now. If you are having issues after a machine gets calibrated and you're recalling the reference system, we should throw in, give me an email and we can help you enter in the recall stage square system there. So those are some good habits to get into to make your programs last long. If you get new glass, if you get new stage squares, different fixturing, it's good habits to get into. So let's talk about different systems that we can create. So the very first one, which we did already today, is we did line intersection point. Couple of things on here that I want to talk about, even though line intersection point you guys are probably sick of talking about, is when I do a system like this, I want to do, let's get that more in focus there. Camera's not liking the focus today. So I'm going to do, I did recall stage square, and I'm going to do line, and I'm going to do F-scan line, and measure this corner, and measure this corner. Now, I want to skew to a really long line. I don't want to skew to very tiny lines like this. This is probably around, let's say, 100, not even 100 thou. The length of this, we can actually see if we go to tools, playback options. I think it tells us, or tools, configure summary reports. I think, yep, length X and Y. So that length of that is 0.2 in standard there. So it's very, very small. But if I set a system, so I do point intersection to these two lines, and I set my origin to 0.4, and I skew to that bottom edge, at least it locates the part. So say your part fits a little sloppy on the fixture and it might move a little bit. This at least locates the part slightly. So we can call this part locating. And then, and this is a good thing to do too with semi-automated programs. If it's not fully automated, you can do two quick lines. And then since we have a system that locates our part, now we can come down and measure more of this edge. So I'll do a new line, more inputs, and I'm going to click on that bottom edge. So if you see in my inputs, it's taking that line on the very edge of it into account. And then I can add to that line and make this a longer skew there. And now I'm going to do my focus point, which remember, do high magnification and come down to like 68, 95 or whatever numbers you have right here. And do a focus point. And now I'm going to set my really good system. The three things that make a really solid system is origin, just X and Y to a point. So think of intersection point, origin of Z to my focus point, and skew. Now I can skew to that really long edge there. And I'm going to call this my datum system. And now I can go move around and measure my part from here. Line intersection point is a good solid system if you have sharp edges. Not everybody makes straight parts. If you're making, just O-rings, diameters, that kind of stuff, you don't have any straight edges to measure to. This one's not for you, but if you do have straight edges like your stage square or your fixture plate, you could use it for setting and storing those systems onto that one. The next one I want to talk about is circle line. So if we want to set a system to a part that we don't have we don't have a sharp edge, but we do have a diameter and a line on our part, we can set an origin to that. So I'm going to come over here, and I'm just going to use this circle again that we were talking about. See if my focus wants to work now. There it is. So I'm going to do recall reference system again. I'm going to do the stage square, click OK. And then I'm going to measure a circle again. I'm going to do circle, more inputs, F-scan arc, because I can't see the whole diameter in my camera window. And I'm going to measure this circle. And then looking at this part, if I come over here, I got a nice long edge over here. So I'm going to do profile light so I can see the outside edge over here. I'm going to do line, more inputs, F-scan line. Now this part, like I was saying, you want to make sure that it's within 45 degrees of how you, I did say 45 degrees of your X or your Y on your machine, but as long as it's 45 degrees of how you programmed it, you'll be good to go there. So I'm going to do, let's do a focus point. With highly reflective parts, I always like to check to see what axial light looks like to see if I could see more definition in the focus. And if you change the lighting after you've taken the tool, after you've taken the measurement, always remember to update. So I just clicked on that green crosshair and it updated it. So now it's storing that lighting setting. So now I'm going to set origin, deselect Z to my diameter. And I'm going to set my origin Z to the focus point. And this time, I normally don't click skew X or Y if my line is within 45 degrees of my machine X or Y. But this case, since my part's kind of crooked, but I want this to be my X skew, this time I'm going to click skew X to this guy. And then now when we hit the PCS view, my part's straight, how my blueprint probably looks, but we can see that that's my stage square. So my part's crooked, but since we set our system and our skew to that, we're good to go. I have talked about this before, but the reason that I don't click skew X or skew Y to an edge, if my edge is within 45 degrees of the machine X or Y, is because if you like to click left to right on a semi-automated program to hit that line, and then your operator clicks right to left, it'll flip your whole program. But if you don't click skew X or Y to that edge, it knows where it's at, and you won't have that issue of who's clicking it which way or the other. I see Rick saying, I relabel the features for recalling further down the program. Line 6 becomes skew. Yeah, that's perfect too. One of the things that I say that's a good little note to pop in here is we could say that this was our origin of X and Y, or if we have datums on our blueprints, I could call this datum B, and then I can call this datum C, and then I should have measured a plane if this was datum A, and then I can recall these later. Or, like Rick was saying, which is a great tip there, Rick, is we could just say skew, rename this to origin XY, and our origin of Z. Because not all blueprints have datums, so we could just call it, which we have here. And then this system, we could call it our origin XYZ. And then I'll also, when I flip working planes, I'll also say like it's system XY. So whatever working plane I'm in, I know that's in system XY that the machine's looking in XY right there. So now when we run the program, it's able to find it. And even if we skew to an edge that is not perfectly an X or Y of the machine, we're good to go there. So if I move this part just slightly a little bit, as long as this edge that we measure our skew is within 45 degrees of how we programmed it, you'll be good to go with a semi-automated program. Fully automated program, it's always going to be in the same location, so you're good to go there. The next system I want to talk about is circle circle. I'm going to do file new here. Let's move over to this part we have over here. Let's see how this diameter looks with profile light. I use F-scan tools a lot. If you guys like Best Edge tools, they're just as accurate and just as repeatable. I like the fact that I can say with confidence that when I do a circle with F-scan features. Every F-scan that I take, I'm placing 100 points on there. So I'll come over there, and then since I have to move the camera a little bit, I might have been able to see that whole circle in the camera window. Let's see on the other one. So I'm going to do circle, circle for an origin. So on this part, on the other side of my part, there's a little slot there, keyway. Looks like it's just big enough that it fits outside my camera window. So now I'm going to do another circle, more inputs. F-scan arc's already selected. Measure this diameter, or this side of the diameter. And then let's get a focus point. Another thing too with semi-automated programs, even if you have datum A as a plane, do one system with just a focus point to establish your Z, and then since you'll create a system, then go do the plane, because instead of you wasting time finding the 3 to 4 points for your plane to get your program up and running, throw one focus point on there and then let the machine do the work for you after that. So I see, two kinds of people out there. Some are visual, some aren't visual. And I've said this a million times. If there's less clicks that I can do to program faster, I'm going to do that. So I have the 3 things that I need to create my system: my origin X and Y, which will be the center of this diameter; my origin is Z, which is my focus point, and then I can skew between 2 diameters. So when I do that, set my origin X and Y, when I click on my circle, it knows where the center point is of that diameter. So it knows to set the origin X and Y to the center of that diameter. And then when I set my origin as Z to the focus point, and then I can click skew, and I can click my 2 diameters here. Now it's skewing to an imaginary line that's through the center of the 2 diameters, the center point of the 2 diameters there. If you're more of a visual person, which you can do if you want, you can do point, and we can click on the diameter so we see the center point of that. And you can also click line and click on your 2 circles. So you can either click in the schematic window or you can click in your features list, and it creates that line between the 2 center points. So now we can do origin X and Y to that center point. We can set origin as Z to my focus point, and we can skew to that line there. And remember, you can always hit PCS view to straighten out your part to be in alignment with the system and skew that you just set right there. So when we run this program, it's not going to take any extra time to create that center point or that line. So you're not adding run time to your parts, but you're just adding a couple extra clicks and time when you're actually writing your program on there. But when you go to explain to some individuals that might not be able to imagine that line going between the 2 because they can't see it, it might be a better visual thing to have the actual line that you're skewing to there. And just so happens that line 6 is our skew. So I'll do this again, that's our skew. And this is our origin of X and Y. So we have that one where circle, circle, line, they can be 2 different circles of different sizes. They'll have 2 different center points. So in this case, if we come over, I'm going to go find that keyway that's in the middle of this part. Come down, I got this side of the keyway. I'm going to do a diameter. I'm going to do an arc here. And then if I come over to my other side, I'm going to click more inputs. So we could also do, here's a couple other things that we could do actually, is that we could set our origin X and Y to that center diameter, origin of Z to our focus point, and then we can skew between the left diameter and our center diameter. So we can do that as well. Or if you wanted to, you could set your origin to the outside diameter, whatever your datum structure is, whatever might be going on there, and skew between those two as well. So circle is really nice. I use that a lot if the datums call out for it, or if the datums don't call out for it. Circles are really easy to measure, especially if they do fit in the camera window. It's one simple tool that you can just hit on that diameter and good to go there. The next one that I want to talk about is bisecting two lines and actually taking the tip of a part here. So I know a lot of our customers make drill bits, make medical instruments, all sorts of different things. So if this applies to you, great. If it doesn't, think about, even if it's not a feature like this drill tip, if there's any other thing that you can do that applies this type of skew to it. So I'm going to turn on my surface lights and just give you guys a little view of what I'm measuring here so we can see this type of drill. I'm actually not sure if this is a medical device or if it is a just a construction type of drill we have going on here. I have many boxes of example parts and demo parts throughout the years. So what I'm going to do here is I'm going to do line, bisect, line, and then I'm going to take a point on the very tip of this drill right here. So I'm going to do recall, one of my systems that I want to use. I'm going to do line, F-scan line, and I'm going to take the left edge of my part, and then I'm going to come over here and take the right edge of my part. So now I have my two edges going on here. Then I can click line, and I can come to our bisect. So think of bisect as our center line, our center edge. So I'm going to click bisect, and I'll click my two edges, and now it'll ask me, do I want the center edge or this edge over here? I personally haven't seen an application that I would use this bisect edge, but if you have an application that you use that you select this one, I'd love to hear about it, so shoot me an email. And then I'm going to come down to the very tip of my part here, and I'm going to use a tool that you guys might not use all the time or ever, but I find a lot of use for it in threads and sharp edges. And instead of doing line intersection point for a theoretical sharp edge, I'm actually going to get that sharp edge there. So I'm going to do autofocus. So I'm going to click point. And then remember, our red icons like to stick on, so make sure to turn them off anytime that you use a red icon, a construction icon. And I'm going to come to this closest edge tool. The closest edge tool is when you click once and you start moving away from it. So I release the mouse, it creates this box with a red arrow looking in this direction. We can expand this box as much as we want. So these blue lines that are on the edge, it's just scanning the contrast. It's not measuring it. It's not placing points on it. It's just measuring the contrast. It might be hard to see on your screen, but there's a pink crosshair that's on the very tip of that part. So it measures all this contrast, and it finds this red arrow is looking in this direction. It's going to find the very first point of contrast that it can see in the direction of this arrow. So if I flip this, so if I click that green square and I flip it, my pink crosshair is up here because that's the closest contrast. That's not what we want. We can click this, flip it, and hit that point. Now, if your part is close to your glass and your glass is all scratched up, so there might be some contrast within this box, we could delete this input and actually use farthest edge. That it does the opposite, that if I click on the very tip of it and move my search window this way, now it's doing the same thing, that it's scanning that edge, but the arrow is looking in this and it's looking for the farthest point away from the arrow. So that might be a safer bet for more repeatable programs if you use something like this. If you can see any contrast, dust, scratches, your fixturing, anything in this area here. So now I do, that's kind of a turned surface. So that actually, I might not want to use that as my Z. I'm going to come up to find where I can see kind of the apex kind of turn of this. And a little trick is if I use axial light, that axial light will show me right where the top part of my turn part is. So this is really good for any turn parts that you have going on here. Ideally, you would find a better flat edge to set your origin to Z, but if you don't have that option and it's just a strictly turn part, hit your axial light, see where the very top part, of that turn part is. So now I'll do origin of X and Y to the very tip of my point. I'll do origin of Z to my focus point, and I'll skew to my bisect edge right here. So that's nice that I'm skewing to the center line of my part, so that helps me orientate my whole part there. So some of these applications might not apply to your parts, but think about it like, all right, he did line, bisect point or bisect line, and then he did just a point randomly there. Think of point as intersection points or point as the center of a circle. Anything that's a point can be your origin of X and Y. So see if it can apply to any of your parts. So the next system that I want to do is I'm going to do a system without a skew. So I got this part here. I'll try to show you the best I can. It's a turn part with many different levels of diameters, but there's nothing on this part that the rotation of this part would matter. So however I put this part in here, if I rotated it a little bit, all the features, all the diameters are still going to be the same diameter and same points taking those diameters on there. So there's nothing really that clocks this part. If you're unfamiliar with the 6 degrees of freedom that these origins and skews are controlling on our part, I love to talk about it. So shoot me an email and we can talk about the 6 degrees of freedom. So I just turn on profile lights, but that's not a through hole. Thought it was. Let's turn on surface lights. Turn on axial. That looks like a good diameter that I'm going to get there. And so circle, let's make it fully automated. Circle, I can see this whole thing. So I'm going to do F-scan circle, bring in my guard band so it fits in my camera window. And then I would do focus point. So I'll do origin. I'm going to set origin of X and Y to the diameter, and I'll set my origin of Z to the point. And I don't need a skew because no matter how this goes on, it really doesn't matter. If you would like to, you could set a skew to the stage square or your fixture, or in this case, I have 2 bolts that go into my threaded plate that I could do a skew between the center of these 2 bolts to get a skew going on there. But if it's a part like this that it doesn't matter the rotation of it, you're good to go there. Now, if we had true position from this center hole to one of these outside ones, you might have a concentricity call out still on some older prints on that. Say the true position's out or the concentricity's out, you have no way of telling the machine operator or engineering or whoever you might need to talk to of where the true position's out or the concentricity's out. So if you're allowed to, maybe take a little Sharpie on your part and draw a line so you can say like what your 12 o'clock is on that, just in case anything needs to be fixed on the part. All right, the last one that I want to talk about is actually line, bisect line, and intersection point, which I'm going to switch out my fixture here, take some of these parts off. Doing good on time here for my Eastern time zone customers. It's almost time for lunch, or maybe that's why everybody's going to be viewing later is because it's during lunchtime. So let's put on this other fixture here. Let's go find my part. If you were on my very first webinar, that was about 2 years ago, probably this week or last week, I use this part to do some programming with DXFs, and I actually did this system way back then. I think that's the only webinar other than the last one we did that I didn't have recorded. But so on this part here, this part is if you've ever changed out your headlight, this is a little plastic connector that is either connected to your headlight or connected to the light bulb that you'd be replacing. So I want to do line, line, bisect line of those two, and then I'm going to do a line here so I can intersect that bisect line and this edge down here. So since this is a white plastic part, it's kind of like grayish a little bit. I just want to see what axial light looks like, because sometimes on white parts or really light parts, axial light makes it look like a brown, which would give us some better contrast there. Let's do File, New. I'm going to recall stage square. So I'm going to do line, F-scan line, measure this edge. I'm going to flip this arrow because there's less noise going on here, less like a gray value coming from the outside, actually the inside into the part. And then I'll do the opposite direction over here. So I'm going to click on my line, flip my arrow so I get a good scan there. I'm going to do line, bisect line. You can also click and drag a box around those two features if it's the only features, and it'll select that. So now we can see here that we have our bisect line. Now I'm going to do another line, turn off my bisect line, and I'll measure this edge. And now I can do point of intersection between my bisect line and my top edge. So I get a point, and it's the center of my part, and it's the very tip of this direction. And for good practice, I've joked around a lot this, if you've had recent classes, if you go to do a focus point and the last thing you did was an intersection point and you call me and you're like, hey, why is all my features grayed out? I can't click on my focus point. Remember to look at your red icons. Again, they like to stick on and you can't intersect a focus point, so it won't allow you to do that. So if you notice that your features or your tools are grayed out, remember to look at your red icons. So I'll do a focus point. So now I can do my origin of X and Y to my intersection point, my origin of Z to my focus point, and we can skew to my center edge there. So that would be another good system to control something that maybe has the center line of the part is datum C. This is datum B, and then the top plane would be datum A. That's how I would interpret that print, saying that the very intersection of the center line and where it intersects this would be my origin of X and Y on there. So that's a handful of systems that I commonly use. We talked about fully automated systems, recalling systems, and setting fixture systems. If you have any applications that you're having difficulties with your fixturing, if it's kind of like the Lego sets, like I'm blanking on the two companies, but like Renishaw makes fixturing kits with the threaded hole plates. We make threaded hole plates. If you have those type of things that you're having difficulties storing systems, that's what I'm here for. Give me a call, give me an email, whatever might be going on. I'm here to help. Just again, we have Warsaw, Indiana training next week. A few seats open for all classes. You can do one class or you can do all week, individual sessions. Feel free to reach out to me for that. Elgin, we have about half the class full right now, so there's still plenty of seats. Our new training facility and our future home of ATI, the rest of ATI will be, it's Randall and 90, basically. So once we get everything built out for the lab, I'm sure we'll be inviting you. But the training center is up and running. That'll be June 7th through the 9th. Again, this will be on our YouTube channel probably next week sometime. But thank you again for registering. You guys, awesome for joining live. Again, if you're not able to view live, please still register and I'll get you the information or tell you to go to the YouTube channel for future viewing on there. We do have a few minutes. Feel free to jump off this webinar, or if you have any questions or want me to do anything again, feel free to pop it in the chat box. I'd be happy to. I got my box of parts over here of everything that I can do some different systems on there. If not, thanks again for coming on today. And I'd love to hear from you guys. If you guys do any really crazy systems, if you have some difficult systems, crazy datums, anything like that, I'd love to hear about them because I always love to learn from you guys. But hope you guys have a great rest of your Friday, great weekend. Here in Chicago, it's supposed to be rainy and thunderstorms. Hopefully we have some nice weather to grill. But yeah, thank you all. And I'll be sticking on here for a while. If you have any questions or want me to go over anything again, pop it in the chat box. But you guys are always awesome. Thank you so much.